Hello, this is Ms. DB. In this video, I'm going to review some of the problems from the polynomial function graphs. So the first part we're going to do is we're going to graph by hand some polynomials. So we're given the function f of x equals x to the third minus 6x squared plus 10x minus 4, and we're given a bunch of points to use for x. You can either choose to do number 1 or number 2. Neither one is harder or easier than the other one. I'll just start with number 1. So we're going to put our x values in to our table. And then you're going to find the value of y, and then we're going to plot these points on the graph and then connect them with a smooth curve. Now you might want to print this or a different copy of some graph paper and do this by hand. It's a little hard to draw with a mouse, or I'll show you how to do it with my word tools. So for this one, you're doing it by hand. You're not graphing with a graphing calculator or a Desmos or something. So for -1, you have to plug -1 in for each of these x values and then solve. So I'm just going to copy this down here, and then I'll replace the x's with each value to find y. So x is equal to -1, so I'm going to put that in parentheses, and I'm just going to replace all of my x's with -1 for my first value. This one might be a little easier because it has less negatives than the other one. Alright, and then I'll simplify. -1 to the third power is -1 minus 6 times -1 squared. I don't want to do too much at once, so I have -6 or minus 6 times -1 squared is 1 plus 10 times -1, that would be minus 10, and then minus 4. I could have just rewrite it. That's minus 6 minus 10 minus 4. Lots of negatives, so be careful. -1 minus 6 is -7. -7 minus 10 is -17. Minus another 4 is -21. So my first point would be at -21. So I'm going to insert on my, I'm going to go to Insert, Shapes, and I'm just going to pick a point. For my point, I'm just going to pick a circle or an oval, and my first point is at -1. See that the x-axis is quite spread out here? So -21 would be like way at the bottom here. Close enough. And then I'll do the same thing, except I want to change all of these to 0. This will be an easier one to simplify, because all the zeros make it much easier, because anything times 0 is 0. So 0 cubed is 0, minus 6 times 0, plus 10 times 0. All I'm left with is -4. So my next point, I'm going to insert another shape. Same thing. And this time I need a point at 0, -4. 1, 2, 3. Here's -5. So this must be going every 2 units. 2, 4, 6, 8, 10. So -4 would be like right there. And then we'll repeat this process for the rest of these values. And as you get the points on here, you will start to see the shape of your graph. Now I'll just do one more. I'll do it at 1. 1 cubed is 1. Minus 6 times 1 squared, that would be minus 6. Plus 10 minus 4. So 1 minus 6 plus 10 minus 4. So 1 minus 6 is -5. -5 plus 10 would be +5. 5 minus 4 is 1. So my next point to insert would be at 1, 1. So here's 1, and up 1 is just a little bit above that. So I can see that it's not going to be a straight line, it's going to be a curved line. And I could graph this on a graphing calculator, Desmos, to get a better idea of what it's going to look, but I bet it's going to kind of go like this and then like this. Because it's a cubed, it's going to have 2 turning points. So it's probably going to go like that. Should we do one more? At 2, I would have 2 cubed is 8. I want to do one more to kind of see what's going to happen, and then I'll draw a line. It won't be a straight line, it'll be a curved line. So for this one, I would have 2 cubed is 8, minus 6 times 2 squared is 4, plus 10 times 2 is 20, minus 4. So 8 minus 6 times 4 is 24, plus 20 minus 4. All right, so 8 minus 24, let's check this one with a calculator. 8 minus 24 plus 20 minus 4. 0. All right, so my next point is pretty much where I thought it was going to be. Insert another point at 2, 0, so right on the x-axis. All right, now I know I have more points to do, but I want to show you how to get under shapes, you want one of these squiggly lines. See these different squiggly lines? Now mine is under recently used. But under lines, you can get these. You don't want the sharp ones, you want one of these curvy ones. And this one actually lets you do whatever you want. These will give you a nice curve, and this one would be a good one, but they're a little bit hard to get them exactly where you want them to go. So I'm going to start with the scribble one. I'm going to start down here. I'm just using my mouse right now, so you can see that it's not very smooth. Now, I didn't do the other points, but I think they're going to be somewhere around here, and I would adjust them, of course, based on where they end up. Now I'm going to just go back and I'm going to try the other freeform one that has a little bit more guidance to it. It will be more smooth, but do you see how hard it is to make it like fit where you want it to fit? And then you can like move it around. But it's hard for me to get the points to be right where they're supposed to be. So I'm going to delete that and just stick with my scribble one. And like I said, you can also just do this on a piece of paper and then attach a picture of your work. That might be easier. And again, I might have to adjust this based on where my next points lie. So I might have to delete this and do it, but it's going to look something like that. All right, so number 2, you can pick to do number 2 instead. Now here's some information about end behavior. End behavior is what is your graph doing as it approaches, as x gets smaller and smaller, or as x gets bigger and bigger. So in this one I did up here, as my x became more and more negative, in other words, as it goes this way, it's as x approaches negative infinity. What is y doing? Well, y is also going down. So y is also approaching negative infinity. That's how you would read this symbol. And in this problem, as x gets bigger and bigger, as x approaches positive infinity, that means it's getting bigger and bigger, my y value is also getting bigger and bigger. It's going to increase and increase and increase. So that's what sometimes happens for polynomial functions, but not always. We also, let me move this back, might get, other things might happen. Like when we had quadratics, they were parabola. In this one, as x gets smaller and smaller and smaller, y actually gets bigger, or the function. So when it says p of x, that's the same as y, just function notation. And as x gets bigger and bigger, y also gets bigger and bigger. Or the other thing we looked at for a quadratic is when x gets, if it was upside down, as x gets smaller and smaller, y gets smaller and smaller, and as x gets bigger and bigger, y also gets bigger, smaller and smaller. Or this one, you can have this kind of situation. So if it's an odd degree, like x to the 3rd or x to the 5th, it's going to look like one of these two kind of things. And we already know that x squared will look like one of these two, but also x to the 4th will look like one of those, and x to the 6th will look like one of those. So that helps you decide how your graph should look. This one is cubic, it's x to the third, which is odd, and the leading coefficient is greater than 0 because there's no negative in front of it. So it's going to look very similar to this one. This one also had a positive leading coefficient. It was a positive x to the third. If it was a negative x to the third, it would resemble this kind of a graph. Here's some other information, maximum and minimums. You can have absolute max and min, also called global. That is the biggest it'll ever be in your graph. Or you can have a global minimum, which sometimes it does and sometimes it doesn't. Like in this example, there's never a minimum because both sides would get smaller and smaller and smaller. But you can also have local maximum and local minimum. That's just within a region. You might have a small point within this section here, or you might have a maximum within this section here. So it's like a high point or a low point. And you can find those points, you can estimate them from the graph. And this is something about roots. A root can pass through the x-axis, that's just a single root at that point. If it just touches the x-axis at a point, there's a double root there. And you can have the y-intercept, that does not have anything to do with maximum or minimum. It might, but it doesn't have to. Like in this example, there's actually another point that is a little bit less than that, like, you know, right about, can't draw it. I don't know, it's about right here. I can't get it on there. That's all right. There it goes, okay. So this would be the, right here would be the absolute minimum at that point right there. And this would be a relative minimum, and this would be a relative maximum. There is no absolute maximum in this one. So once you know all that, you can evaluate graphs, you can gather information about them, and fill in as much stuff as you know. These are called critical values. We can also find domain, range, and behavior. The domain and range was given in this. You can find that the domains might be, the domain is always all real numbers, but the range is going to be different depending on if it has a absolute minimum or maximum, like in an even degree function. Okay. So let's look at number 3. So x-intercepts, roots, solution. So we look at this and we say what are the x-intercepts, that is where it touches or crosses the x-axis. So I can see that there is one at -6 and one at 2. And if you can't tell the exact point, you can estimate what that is. And those are both double roots, because they both just touch the x-axis but do not cross. So -6 and 2 are both double roots. The y-intercept is where it crosses the y-axis. It looks like that is at -5 in this. The minimum value, is there an absolute, oh, first maximum, is there absolute or relative max? There are 2 maximum values. They are right there and right there. The maximum value is the y value at that point, not the x value. So the maximum value is 0 in 2 different places. That's the highest that this graph will ever go on the y-axis. And it's actually an absolute. So I'll highlight that. And let's see, a minimum value. There's a relative minimum here. That looks like y is equal to -8. And that is a relative, because there is no absolute minimum in this one, because both as x approaches -infinity and as x approaches positive infinity, y also approaches -infinity. My domain is all real numbers, because there's nothing that x cannot be, but my range is never higher than 0. So you would write that y is less than or equal to 0. End behavior. So this is what's happening. As x approaches -infinity, so as x gets bigger and bigger, f of x, or y, is also approaching -infinity. You can type infinity, or you can find it on the symbols key. And as x approaches positive infinity, y is also approaching positive infinity. So the function approaches, oops, negative infinity. I meant to write. So they're both going down, so that's negative infinity for both of them. And that's how you will do number 4, 5, 6. No, just number 4 and 5. Okay. For 6 and 7, you're going to make a sketch of this by hand. You can again use your tools in Word, or you can do it by hand and take a picture of it. So it says that we have zeros at -1, 1, and a double root at 4.5. So zeros mean that it's going to cross the x-axis at those points. So I'm going to put a couple points at -1, would be right here. And I'm just going to copy that and paste another one, and another one. Whoa, that one got big. Another one there. And another point at 4.5, but this one will be a double root, so it won't cross there. It's just going to touch there. So I'm going to go ahead and insert that, that drawing tool that let me just do it freehand. So that scribble tool, I guess you'd call it. And it doesn't say anything about, it says it's a cubic, so I know it's going to have 3 spots of inflection where it kind of turns, and this one is just going to, I wasn't done and it stopped me. I'll try to finish that. So I need to finish my graph. I wanted this to touch right at that point, and it doesn't look like it does. Let me see if I can adjust it at all. Yeah, you don't want to spend, all your time on trying to make this graph look right. So 1, 2, oh, I've got too many points of inflection. That would be an even, so I need to adjust this a bit. Let's see, how could I adjust this so that it would be a cubic function with a double root at 4.5. Actually, if it has a double root at 4.5, this would not be cubic. This would be quartic. It would be a fourth, because 1, 2, 3, 4. So my drawing was okay because it would have 3 points of inflection. I just need to fix the worksheet. So I'm going to go ahead and make that go down again. So a quartic function should have 1, 2, 3 points of inflection. It'll have 1 less than the fourth. And because these are both going down, it would be negative x to the fourth. Now I could have drawn it the other way with a positive x to the fourth. And then there'd be some other stuff after it. You don't have to do that part, you just have to do the drawing. This one says 4th degree. So we have 1, 2, 3, 4 roots. So you'll put those 4 points on. And then this one tells you for the end behavior. So this says as x approaches positive infinity, it should also approach positive infinity. So it means it's going to go up at that on the right side. And as it approaches negative infinity, it also is going to go up on this side. So you put your points in approximately where they are, and then you get to sketch a graph. And everybody's will look different, knowing that you have to end up, oops, I didn't end up in the right spot. So that won't work. So let's see, I know I have to start. There we go. Something like that would work because then it goes through all of the roots and they're all single roots, so I don't have to worry about that. And my end behavior is correct. All right, these are much easier because we can use Desmos or Sketchpad. For one of the problems, find the x-intercepts, y-intercept max, min values, and describe the end behavior. So don't forget to do this for one of the problems. Pick your problem to do it with, and paste that in there and find this for each one of them. And then don't forget to paste your graph. For the next part, you're going to write down whether it has an odd degree or even degree, a positive or negative leading coefficient, and name the approximate real zeros, and name any double roots. So for the odd or even degree, you can go back to the chart that had the end behavior. This will be helpful for that. And for the roots, remember that if it goes through, it's a single root, and if it just touches, that's a double root. So this is very similar to some of the other problems we've done. You might want to paste this chart on here for easier reference. So this one right here, since they're both going up, It's similar to this, so it's an even degree, I know that. It's a positive leading coefficient because it's pointing up and not down. Approximate real zeros are at, what's that, about negative 0.8 or so, and there's another 0 here, and that's at what, 0.3, and there's a double 0 at 1 because it just touches there. And that's all you'd have to say about it. And you do the same thing for number 13. All right, thank you very much. Good luck with this. Let me know if you have any questions.